You ever notice a small change on a website you use all the time and wonder, why'd they do that? Chances are it wasn't just a random guess. It was a calculated move, backed by cold, hard data. Today, we're going to pull back the curtain on A/B testing, the secret weapon that companies use to figure out exactly what works. It's how we prove that when it comes to making smart choices, data beats opinion every single time. So let's jump right in with a super simple question. Imagine you're running an online store. You've got this Buy Now button, but you've got a hunch that maybe, just maybe, a different color could get you more sales. So, do you go with blue or do you go with red? What does your gut tell you? Go on, take a guess. This exact kind of problem is what A/B testing was born to solve. Okay, so whatever color you just picked in your head, that was based on a hunch, right? An opinion. And you might be surprised to learn that for decades, some of the biggest decisions in business were made the exact same way. So in this first part, we're going to look at that massive shift from a world of pure guesswork to a new approach that's all about hard evidence. And here it is, side by side. The old way, the traditional method, it's all guesswork. And that's not just risky, it's often biased by, the opinion of the highest paid person in the room. But the data-driven approach, it flips that completely on its head. It's controlled, it's objective, and it gives you undeniable proof of what your users actually want. So what is A/B testing, really? Well, at its core, it's just a simple, controlled experiment. It's like a head-to-head competition. You take what you have now, that's version A, the control, and you pit it against a new idea with one single change. That's version B, the treatment. Then you show each version to a different group of people and just measure. You see which one performs better. Simple as that.
But, and this is a big but, to get results you can actually trust, you can't just wing it. There's a real structure here, a process that turns this simple idea into a legit scientific method. So let's walk through those exact steps right now.
The whole thing follows a really clear path. You always start with a problem you want to solve. From there, you make an educated guess, a hypothesis about what might make things better. Then you create your two versions, A and B, split your audience right down the middle, and show each group just one version. After that, you just let it run, collect the data, and analyze the results to find your winner. Now, before we can prove our cool new idea actually works, science tells us we have to start with the opposite assumption. It's called the null hypothesis. So for our button example, the null hypothesis would be changing the button color makes absolutely no difference to the number of clicks. It's kind of the boring default state of the world that we're hoping to disprove. And this is what we're actually rooting for, the alternative hypothesis. This is our big idea, our bold claim. For our experiment, it's the red Buy Now button is going to get more clicks than the blue one. The entire point of this whole A/B test is to gather enough evidence to see if we can confidently say, yep, this statement is true. Okay, so we've got the whole experiment set up. But this is where it gets really, really interesting. See, it's not enough to just see that the numbers are different. We have to be absolutely sure that the result we're seeing wasn't just a random fluke. All right, the data is in. We showed the blue button to 500 people, and 50 of them bought something. That's a 10% conversion rate. Not bad. Then we showed the red button to another 500 people, and 65 of them bought something. That's a 13% conversion rate. So the red button won, right? Well, hold on a second. It looks better, for sure, but how do we know? What if we just happen to get a luckier group of people for the red button? People who are going to buy something anyway. Could this 3% difference just be random chance? This is where we bring in the big guns, statistical significance. To be sure, we calculate something called a p-value. Just think of it as a fluke detector. It tells us the exact probability that we'd see a difference this big, even if the button color made no difference at all. And if that probability is super low, the industry standard is less than 5%, then we can confidently reject the idea that it was just luck. That's when we know our result is real. A huge part of getting that confidence comes from testing on enough people. I mean, if you only showed each button to 10 people, 1 or 2 random clicks could completely throw off the results, right? A large sample size is crucial because it helps smooth out all that random noise and lets the real trend shine through. And randomization, that is the absolute bedrock of a good experiment. It's non-negotiable. By randomly assigning people to Group A or Group B, we make sure that the only real difference between the two groups is the one thing we're testing. That's how we kill bias and make sure we're actually comparing apples to apples. Okay, now that we're clear on how it all works, Let's zoom out a bit, because this isn't just some abstract idea. It is a fundamental tool used by the biggest, most successful companies in the world every single day. Seriously, this method is everywhere. E-commerce sites are constantly testing prices and button colors. Social media platforms test new features on a tiny slice of users before rolling them out to everybody. Ever wondered why the thumbnail image for a show on your Netflix account is different from your friends? Yep, that's an A/B test to see which picture gets more people to click play. This process is constantly shaping our world. Now, if you're getting excited about trying this yourself, be careful to avoid these classic mistakes. First, don't stop the test the second one version pulls ahead. You have to wait for it to be statistically significant. Make sure your sample size is big enough. And please, only change one thing at a time. Otherwise, you'll never know what actually caused the change. And finally, resist the urge to constantly peek at the results. It can trick you into stopping early and making the wrong call. And really, that brings us to the most important takeaway of all. It's a simple, powerful mantra that separates the best from the rest. If you are not testing, you are guessing. So I'll leave you with this thought. Now that you understand this incredible power of moving from guesswork to data, what's the one assumption in your job, your business, or even your life that you've just been taking for granted? What's the most valuable question you could finally get a real answer to with just one simple, structured test?